Hello and welcome. I'm Bill Wake. We're here working on a top simulator. We've been doing it for a few episodes, and today we're going to work on concatenating patterns. So the focus of that is, I'm going to imagine I have two patterns. These are X's representing pixels that are on and O's that are off. So I have sort of I don't know, a hangman's noose thing game on the left, and on the right we have a little bit of a vertical bar with some gaps. And then when we add it together, we're appending each of corresponding rows together and filling in blanks. So if the last row, it gets 0, 0 because we can tell it should be too wide, and it doesn't have anything specified, so we want to have those blanks there. And actually, we could omit stuff from the left-hand side too, but yeah, it's just one example. All right, and the idea with this is the top itself is, well, it's a round top with a row of LEDs, and the fun part of it is you can turn on the LEDs on and off, and if you do it in a certain rhythm, you get a pattern. And we had the simulator working with specifying how long should be on or off, but if you're trying to actually design patterns, that's a real pain. So we switched and said there's going to be a little designer mode where you can create little pixel grids, and then at sort of design time, you'll concatenate them together, and it'll convert that into the list of arc on and off times. Okay, I heard the bell, so the test did finish. Let's see how we're doing. Yeah, everything's passing. Good. Okay. And then, so yesterday, the big focus was turning this array of Booleans, double array of Booleans, into a class pattern. So, we just had the raw type with all the Booleans in there representing pixels on or off. And we extracted out the pattern class, propagated that around, added a few tests, nothing too crazy. Let's go in there. Okay. So it knows all its info, width, height, both of the maximum of any. It can turn cells on or off with toggle. It fills in false if you ask for something outside of the range. So we have one row of data, row 0, but if we ask for row 1, we get a false. If we ask for column 2, just outside, we get a false. Then we get into this thing of conversion into the arcs. And so if you just have a run of all trues, we get a 2. Now the way it works is this these arcs, they're sort of like they're proportional. So in this one, it's 3 pieces, so into 360 degrees, that's 120 for each. So this should be on for 2/3 of the circle and off for 1/3. And you alternate trues, falses. And what that means is if you have a false first, you have to say there's 0 trues for the first one. So that's why the 0 is leading there. And then this one, we just made sure it worked for all rows. So we're reasonably confident that our conversion to arcs works. This is another bare type, though, a list of double array of doubles. It's probably due for some love at some point too. And I don't know, this is one, it's things get out of hand pretty quickly, right? So, I mean, you've already got this propagated 5 times, 4 times in here, and then wherever else it's used, we're getting a lot of dependency on this stuff. And probably there's a constructor that takes these things because that's natural to build them that way. But I don't know. It'll probably involve some change. But that's not what we're after today. So today what I want to do is I want to deal with the notion of a composite pattern. So like I showed in the intro there, take 2 patterns and append them. And basically, well, let me see. Let me go to a page I didn't show. This is from yesterday. So we have a 3-screen view, and that first view is the top spun with whatever program you gave it. And then patterns, the idea is you're going to have a list of patterns, and you're going to say, A, B, well, how about H, I, exclamation point. And my theory is we'll put spaces between them to represent little thin bars, and you'll just spell out the list of things in here, and it'll go to the pattern library, pull up those corresponding patterns, concatenate them together into one big pattern, and then convert that to arcs for the spin. Excuse me. Okay, so well, let's see. Sometime between the last 10 minutes of yesterday and yesterday evening, I kind of realized, like, okay, I was thinking composite pattern, like you had a simple pattern that's just the array of bits, and a composite pattern that's holding the sequence of them. And I realized I really have two choices. Well, I certainly have at least two choices. One is the composite. The other is I could just make a brand new pattern and just treat them like simple values. Just build up the grid and hand it into the pattern. And I think that might be easier. Whoops, where's my code? Pattern. I'll put this over here. All right, so when you make a pattern, you can give it the array of booleans that you want. So we could build up the new array and pass it in. And I think that might actually be, it's easier in a way. I mean, what's nice about it is you get a kind of little domain, and the patterns produced combined with patterns to yield patterns. That's kind of reasonable. So let's do that. And okay, so I don't think it's going to be too hard to guess the interface for this. I think you've got a pattern. You ask it to append, concatenate, add, plus something, another pattern, and it gives you a pattern back. And then let's just see our content. That's the library. Trying to find the pattern that we're using, the one we're presenting. Maybe it's content body. Excuse me. Content body view. Well, we maybe don't have. Oh yeah. So okay. So when you run Go, we set the arcs in that procedure. So basically, we'll have to dig up the list of patterns they gave us, parse them into a list, and look up each one and call arcs on it. Yeah, so that's basically what we're doing now. We handle one pattern. Okay, so I'm going to take the original, the dashes one where we just had a list of numbers and we use those as the arcs. Okay. Right. Yeah. Okay. And this is the fields we use to enter the old ones, so we'll take that out too. All right, so right now we got pattern names, you call go, everything's good. All right. And so our imagination is the front end does a little bit of processing to parse the list of words or list of pattern names and looks them up and concatenates the patterns. TopMaker library patterns. Let's go to TopMaker. And I'm not quite sure this guy's pulling his weight. Patterns of string. Okay, well, all right. So we're mapping library of strings to args. Dot first. Okay, so so we've done a little bit of parsing work here, but we haven't done the whole job by any stretch. Okay, so at this point we're going to have words, and it's going to look them up. Okay, so I think we can work with that. I think just a sort of an append, or I want something that suggests that I'm adding but not replacing. Maybe join. Yeah. Okay. Let's get in here and do this. Okay. Whoops. Pattern view. I want pattern tests. And I don't know. I just got in the habit of putting them on the left, and when they're on the right, I spend all day looking for them for some reason. Okay. So let's see. So what we're going to do is create. I'll just say join. We can clarify it as we go. Okay, so I'm going to make some sort of pattern. Well, let's call it pattern 1 and pattern 2. And I can put junk in there for a moment. And then let combo equal pattern 1 dot join pattern 2. No. Join does not sound right, does it? Append. Well, let's get the assertion. Combo should be another pattern. Okay. Got to fill in some data. All right. A member has no join. Combine sounds too much like put it in there. Append. I mean, plus. Yeah, let's go with plus. All right. We will run these. Well, let's get some framing done. Okay, so I'm going to start very simple. I'm going to give this thing true. This one false. And the combo should be true, false. Okay, so we're not worrying about cases where things go off the edge. Okay, we need an equals equatable. Okay. We're not worried about mixed sizes of rows or which one has more rows. So we've got equal rows. We're just checking that two values get appended together. Okay, so I got to make a plus, and I got to make things equatable. Okay. So public function plus takes other pattern, produces a new pattern. Okay, and we'll just return pattern empty for now. Okay, and then we need equatable. Now, one thing I've been trying sometimes, I'm not sure, kind of from the language point of view, is this better or worse? But you can do your extensions in the test, test part of the the test set of classes. So let me try that. I'm going to say pattern is equatable to make the test happy. It should tell me what it wants, which is just an equals method, I think. Okay. LHS pattern, right? And then we're just going to return LHS.pattern equals RHS.pattern. And I think that's okay. Comparison. Let's see if there's some other elements equal contain the same elements in the same. That actually sounds more precise, doesn't it? Okay. And I'm not going to deeply test it. I'm going to assume it's going to show up because it's going to break the first time and pass if it works. And if it doesn't do that, then we'll investigate. The reason I pull it there and do it on the test side is, well, it sort of tells people like, you're not really equating these. But it's, I was going to say it's hashable, but it's not. The key's got to be the interesting one. You got to make sure the key can be equated and all that stuff. But the right hand side, we don't care. So nothing on the domain or the implementation side wants it. And I'm keeping the clutter out and keeping people from the temptation of comparing them when I don't really think that's part of what we're doing. But if we needed to, we could move this back over. Okay, certainly this failed. Pattern not equal to pattern. That message could use some work, couldn't it? Well, we'll do another extension. Pattern custom string convertible. Okay, again, it'll tell us we need. Oh, we can't do that one down here, can we? I want debug. Oh, it's not debug string convertible. I think I'm not allowed to put variables in. Yeah. We'll see if it allows this. Return. Well, let's just return pattern dot. Let's return pattern and see if it. Well, no, it needs to be a string. Let's try that. And we'll see if this gives us a little better. We got a syntax error. Oh, no. It's a test. Good. Okay, did you get better? Yeah, I think so. Yeah, that helps. Okay. Not equal to true, false. Okay. So, again, we're kind of in a, well, let's see. Let's let result of, how about, yeah, result of array of bool equals empty. And return pattern result. Okay, then we got to accumulate it. Okay, I guess I want to run through the list of rows. Maybe I just start with row equals 0. And really it's a list, but okay. And we want to go for statement, column in 0 less than. I guess one question is, am I willing to give myself access to the internals of each? You know, I think I'm better off going through the public interface. The height, the width. So width already tells me it's calculated the max, and it's taken into account the fact that rows might have varying sizes, and then this thing also takes into account that rows and columns need to match up. So let's do this. Well, basically we're gonna append the first one's first row according to its width. Okay, and I don't know, I think we're just gonna go there. So results of row dot append, and let's do self dot self sub row column. Okay, so there's our subscript. Can I use mutating member? Oh, result is a let. Not good for an accumulator. Okay. So I'm copying in the first one. So the first row of the first pattern. And then I need to do something very similar. I'm going to get the row from the other one. And this is other sub row column. Okay. And I think this is good. I mean, there's probably some fancy way to write it better, but I think we're doing the way that takes into account these corner cases about widths not being equal and all that stuff. So I believe this will pass. Yeah, tells you what I know. Index out of range. What? You're going to keep going? I thought that would stop the... Oh, right. I've turned the debugger off. Okay, let's see. Product scheme. Edit scheme. Okay, our tests run a ton faster with that off, so by default I leave them off. Let's run just this test. Who's crashing? What do they got? Like I said, it's slower with the debugger on. Okay, can we predict something? Well, we got arrays of one row, one column each. I'm saying row 0. Are you still going to not stop? Okay, there we go. Oh. I guess we have to start empty, huh? Forgot about being a double array. We got to initialize it. And we know it's empty, and we know it's there because it's row 0. So what? Okay. Result sub row. Well, I guess I got to do an append, huh? Arrays in Swift, I want to say they're a little funny. They have their own sophistication. So I was just musing this morning. Like I remember learning how to write array access in assembly language, for whatever back when, and you had some sort of index register, and you would index off either a constant or a register, and it's about one instruction to get there. In Swift, it's a lot more complicated. So they use copy on write strategy. So if you assign one array to another, you're not assigning the object like you might be in Java. You're making a copy, but the compiler has a bunch of stuff compiler runtime combo makes these things to make it so it appears that you get a copy, but as soon as you change something, it says, oh, wait, those aren't really copies. We can't share anymore, and it splits them up and uses some fancy mechanism to let you write the array. And I think it's all coming out of like the functional language world, where they've developed these data structures that are more for immutable objects, and yet you want them to be reasonably efficient. You don't want to have an array that every time you access, every time you write something to it, it creates a brand new array. You create a lot of extra storage. So you've got techniques you can use to let them create storage incrementally and stuff like that. And I think they're just pulling in those techniques. They give the language the simple, you're making a copy semantics, and under the hood, you're not copying it. You're copying a pointer with a thing that checks if you're writing and does all this stuff. So they're interesting, but I don't know. Sometimes I just don't. I don't know if I don't have the intuition about performance. If I copy an array in C, I'm running through a bunch of bytes and moving them from here to there, and I know the expectation of how long it's going to take. If I copy an array in Swift, it's one instruction copy. It's a pointer copy, and it gets more complicated after you copy it. Okay, so that is working. Let's get some sophistication going. Let's get multiple rows. So this is let's do the one from from this. So I'm my article for this week is on symmetries. It'll come out this afternoon, but this is one of the examples I'm using. Like this is, how is this symmetric? Well, it's not symmetric top to bottom. Okay, because if you mirrored it from the middle, the XXX doesn't match OOX. Okay, it's not mirrored side to side because 0 over here would match that. It's not mirrored on this diagonal because 0 goes to X would not match, and 0 to X there. And on this diagonal, it's not mirrored that way either, because this 0 would line up to that X. The symmetry that is there is width equals height. Okay, but I'm combining it with something of a different size, and so this one, it's in effect false, 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 false. So it doesn't really have a lot of symmetry either. And these two, they have different sizes, but we define the size of the whole thing. I'm just trying to I don't want symmetries. Well, I avoid a lot of symmetries because if you if you have a symmetry, you can't tell if you've done something right. So if this were symmetric on the diagonal, we can't tell if we copied, you know, row one, row zero, column zero, um, or did have we swapped our rows and columns and we're transposing it and transposed across the diagonal. If it were the same, you couldn't tell the difference. So I think this is good in that sense that we can be sure we're not messing it up. I don't think there's any. I don't really think I am, but because we row column row column row column, they're all consistent across, so that's good. And the asymmetry of different sizes, I think, pays off too. We want to check that happens because our patterns could be different sizes. Okay, so let's see. I'll allow myself a comment for a moment here. XXX, XOX, OOX. Okay, so this one becomes true, 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 false, true, and false, false, true. Okay. This one well, it was XO and OX. Okay, so true, false, and true. Plus with different shaped patterns. Okay, we combine them, and the result we expect will these two here. True, 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 false. Next line. True, false, true. True, and then we have to fill in the false. And next line. False, false, true, and we fill in a couple falses. Okay. I expect this to fail because we've only done row 0. So I think row 0 will look right. True, 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 false. But row 1 and 2 won't show up. That's not good. What test did it run? It hasn't run this one. I'm not sure what I missed. Okay. Let's see the message. True, 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 false is not equal to the whole big thing. Yeah, so we only did row 0. Let's go back and put this in a loop. Okay. For row... row in 0 dot dot less than, and now we have to be a little clever. We need the max, and I don't know how to get it, but I'm sure you can. Let me get things formatted first. I don't want to forget where my loop end is. Okay. So the max of self.height and other.height. Okay, so we're going through. Again, we're taking the maximum so that we guarantee to get both things. Okay. And you know, I could do the tiny steps. Let's make the experiment and make sure we understand exactly what's going on here. Okay. Self height. So in this case, I would just say if I only did the first pattern, I think my test would pass. Because the big one's coming first. So let's see if that's true. But I expect to pass. Yeah. Okay. And I'm gonna make. Oh no, that's not gonna work. Biggest first. Another duplication or symmetry I talk about is tests that look like the same shape, but we really are intentionally doing this. So we're trying to get the same patterns, but we're going to do pattern 2 plus pattern 1. And then we need to pull these to the front. Okay. And this one we expect to fail because we don't have that max. We expect we'll only get 2 rows. Okay, true, false, false, true, true, false, false, true. Yeah, so we only got 2 rows, didn't compare to 3. Cool. And I expect that'll do it. Okay, and I'm just going to turn that debugger switch back off. Yeah, we can probably improve that a little, but all right. So good, that test works. Now the other thing I want to test, with this is a symmetry that you have an identity law that holds for this thing. So if I have an empty pattern, no bits, and I append it either on the left or right of another pattern, then I should get the other pattern back. Okay, so we're saying there is a symmetry that we want to test. So I'm kind of drawing that distinction in my mind, but let's see. I don't think we'll need much. And, you know, just like plus has a 0 in arithmetic. Okay, so we'll get a pattern equal pattern, and I don't need to be too fancy. True, true, false. Okay, and well, we have an empty, actually. Okay, so we're going to let the combo equal well, maybe I should say left identity. I don't know if I am better off with two tests. Combo should be the pattern. And then the right identity. So the reason they draw the distinction is some operators only have one or the other identities. So like divide, 1 divided by x is not x, but x divided by 1 is. So let's see, this one, the combo is pattern dot plus of pattern dot empty. Okay. And I don't mind writing the two tests together. Although, you know, my talk of symmetry, doing these duplicates here, like another aspect of that, it's not the symmetry in the domain, but it's just the symmetry in your process of what's going to find things. Oh no, what's going on? True, true, false, false, true, false is not equal to true, true, false. Oh. R equals is not sophisticated enough. Oh. Okay, so I'll change this for a moment. And okay, so this is good in a way. It tells me true, true, false, false, true, false is not equal true, true, false should be false, true, false. Okay, it tells me that my result has filled in these spaces, but my equality test is not sophisticated enough to do that. Okay, so all that stuff I said about not having to test the equals, now I feel like I gotta test the equals. Because it's wrong. Yeah. Can't let that go. And I'm testing stuff in my tests. Yuck. But I don't see a way around it. Okay. Let's just do pattern equality tests. I think I can put them in the same thing without problems. Okay, so I just got to make sure my equality works. Well, obviously stuff like this is, well, let's borrow that for a moment. Okay, but the I had learned a nice pattern from James Shore of you test equality, you define two equal ones and one not equal one, and you make sure everything is conforming on that. Okay, so just again, I'll mix this up. I don't think it needs to be quite as big to reveal the problems we have. Okay, so a pattern that should be the same, and I'm going to have several, and I'm going to have some that are different. Okay, so false, true, false should equal the complete identical thing. Okay, but it should also equal this. Okay, so if I compare this and this, should those be equal? They should not. Is that true? I guess they should. It makes it a tricky question, doesn't it? So I'm saying if you want to compare two patterns for equality, you pre-conform their sizes and then test. So equality is not trivial here. Okay, but the way to test equality is to make them conform so they're both the same number of rows and same number of columns, and compare. Okay. I mean, I think I can understand if that seems confusing, but I think it's the right thing. Okay, so this one differs in that last place, so I think that's okay. Okay, so now we do the claims. Pattern 1A is equal to pattern 1B. One A is equal to 1C. And I don't know if James would use the same names I'm using here. Pattern is not equal to pattern 2. Okay. Pattern 1A, these two are identical. You almost could check the pattern against itself. It might be a reasonable thing to do. Okay, so it knows anything should equal itself. We know that's a sort of a fundamental law of what it means to be equal. Hopefully we're not going to violate that with this weird thing about conforming. Okay, so 1A equals 1B equals, we're saying you're equal if you have identical stuff in your, initialized with identical stuff, even if you're separate objects. We're equal by conformance, and then we're not equal when there's an actual difference. Okay, and our prediction is this test will fail. The first line will be okay, the second line should be okay, the third line will not. And I think the fourth line will be okay. Yeah. Okay, so false, true. False is not equal to false, true. Okay. So our equality then I guess I want to run through the loops. Row in 0 dot dot less LHS dot height. Well, it's no, we're going to do the same max thing again. LHS dot height, RHS dot height. And then for column in 0 of max of LHS sub row. Oh no, just LHS dot width. RHS dot width. Okay. And if LHS sub row column is not equal to RHS sub row column, we're going to return false. And if we get through the whole thing and everything was equal, we'll return true. And okay. And you know what? I'm going to make one more test. I'm gonna flip it and just make sure 1Z is equal to 1A. Okay. Again, I think I've covered it with this max thing, but if we'd left it off, we would have sort of presumed the left side was bigger. Okay. And actually, you know what I'm going to do? I'm going to add another false. Make sure that still works. Oh, and I think we're testing our identities now. Okay. Yeah, so the identities were working if you tested equality properly, but you get those surprises, you know? That's one of the reasons we do this stuff. All right. Well, I think it's probably a good time for a break. I've been going a little longer than I usually do here. So let's take a break, and then we'll come back and start integrating this into the UI and see if we got it working. All right. See you in like 2 or 3 minutes. Hello, welcome back. All right. So let's see. We've got a pretty good set of tests, I think. And let's commit this. Whoops. Okay, so we added plus to combine patterns. Alrighty. And I think we've run the whole test. Let's run the app just to see, make sure nothing reverted or regressed. Give us a little direction on where we're going here. So, well, that's kind of ugly. I put a spacer at the bottom. Let's do that. All right. Fix one thing. All right, my patterns library starts empty because it's new every time. I don't know what this word new is on the bottom. Pattern view. Yeah, I really don't know what it is. Pattern editing view, pattern view. No, is it library view? And, oh, am I getting a free pattern? Okay, yeah, I get a couple random patterns. So A43, B39. A43, B39. I think we'll only get one of those. Maybe 0. Okay, we'll have to see. All right, so we got some patterns. I don't really need that button though. Is that an extra? Yeah, okay. And make a new pattern. I'm going to put a little space above. That's pattern editing view. I'm getting myself lost on which what's the difference? Pattern editing view, pattern view. Maybe this is, no, I don't know. It's an actual, you give it a pattern It just displays the pattern. Okay. But this one displays them with a button on it. So pattern view is the display in the library view. I don't know if my breakdown is as good as possible. All right. Well, I guess I need a spacer at the bottom too. Is that the V stick? I think maybe I was trying to decide if there was a way to combine those. I'm kind of a tyro on this stuff. Now, why is the name down so far? Where is that text from? Text field. Edit pattern view has pattern editing view. So who holds this? See, I don't know. I'm just feeling like there's too many screen, too many views running around here. Okay, observed object pattern. Binding to the string. Pattern editing view. Okay, so I guess pattern editing view, we don't want the spacer at the bottom. But we do want it. Well, it seems to have one here. H-stack, that gives it horizontal spacing, and then this should be, maybe we need to put this in a V-stack. Let's find out where it's used. Edit pattern view. Colors? It's called in content view. Okay, so edit pattern view is called at the top level. So I guess I think he should be a V-stack. Has a pattern editing view. Probably a little spacer here wouldn't hurt, but maybe it's okay. All right, so let's see what... I wasn't exactly setting out to do this, but a little tweaking is good. Now, one thing that bugs me is the pattern library. I thought I was getting a grid object that would put like 2 or 3 across, whatever would fit. And I'm not. Okay, no. Oh, yeah. It's got its own spacer now. Pattern view. So I don't want a spacer here. Now I gotta get aware of these. I think these views, like, I need to think of them more like components and really be strict about they only contain the stuff that they, that fits that little piece of things, and somebody outside will format you. Okay, now I think my outside thing should put a spacer above it. Let's see, where did that thing go? That was edit pattern view. See, this thing should be making the decisions about the look overall, and the pattern editing view is just do your job, show a grid, just show a grid. Livable. Okay, so I'm just gonna put well, I thought that would fit more nicely. But anyway, and we'll call it backslash. I haven't got any restrictions on names yet. Okay, but there's that. Now, if I go here and I use backslash, that should work to some meaning of work. We still have this thing that we don't restrict it to a certain size. So each segment, this is a 1, a 1, a 2, a 2, and a 1. Kind of crazy. I don't know. It really should be. If we had done the whole thing in a 15-degree arc, it would look moderately reasonable. I may have the center a little too tight, I will grant you. But okay, that's something. Now let's do 2 slashes, and I think it's just going to display the same thing. Did it? Yeah, it clicked. Okay. So yeah, we don't actually append these things, or if you remember, we appended them and then took a first. Okay, but we did some UI spacing tweaks, I guess I'll say. Okay. Where is our top maker? Top maker. And we just have this one function in here. The thing is, this top maker is kind of a helper for the UI. But, it's like I want to keep computational stuff out of the UI as much as I can. All right, but what are we doing? So patterns trimming characters in space equals empty. Okay, so if it's an empty string, return an empty set of arcs. If otherwise, we're going to split the patterns on spaces, map each name to an arc. That gives us a list of patterns. And patterns, well, this is really pattern names. Okay, let's rename this. Well, no, that's not either. Patterns is a string. It's really like the pattern name. Yeah, pattern names, I think, will be a better reality. Okay. We got a couple tests for top maker, but I'm theoretically I check in after each refactoring, and I'm really bad at it. I worked out a TCR mode, it was just too clunky in Xcode. Maybe I should give AppCode a try. Okay, so refactor, rename field. The bad thing to me, well, no, not bad thing, but it would be nice if I could configure things to detect a refactoring. I mean, I would love it if my IDE, I do a refactoring, I run the tests are green, and it commits. It's like that would be nice for me. And it knows what it just did. It knows I did a rename of patterns to pattern names. Okay. All right. So pattern names, split them on spaces, map them to the library calls, and then I'm gonna refactor this. I'm gonna break up the map. Two arcs. Oh, is it not gonna? That should be okay. All right. So I'm saying look them up and then map them, and then convert it to arcs. So the type of this, let's pull it out. Okay, so I'm splitting this stream expression, hopefully in a good way. Break up the patterns, map them to library lookups. The library is string to pattern, so it's basically converting each one to a pattern. So now I have a list of patterns. I'm going to map them all to the arcs, and I'm going to take the first. Well, this stuff, this is the part that's not really right, but this should still work. And one of the reasons you can do this, depending on your IDE, some of them will tell you, I don't know if I can, let's see, option that. Turns an array, contain the results. Well, it doesn't really give me details. Okay. But I have split this. Now I can see this type is list of patterns. And before, at the end, before it was, whatever my return type is, which is array of doubles. Yeah. I think IntelliJ will let you hover over the individual ones and it'll tell you what the stream is at so far. Very nice feature. But now I've got this list of patterns. Well, that's something I can work with. Now, okay. So where's our top maker tests? Yeah, if you recall, we left off kind of right where we're doing this. Now this might actually pass now if we... Okay. Cannot convert value of library string to bool to library of string of pattern. Okay. Default value pattern.empty. This is why commented out code is not really so handy. Okay, now library of string of pattern default value pattern.empty should be just like that. Okay, now this we have to wrap in a pattern. Okay, top maker library 1.1. So we're expecting two patterns and this thing to come back like that. If we take, well, this should fail. Now I know I'm leaving out one small factor that I want to have spaces in there somewhere, but we'll get things concatenating, and then I can always simulate it. Okay, 1 is not equal to 2 because we did a dot first. All right, so that gives us our reason. Let's see, can I move 2 tabs at once? No. Okay, that gives us a reason to get rid of the first here. Okay, so what I want to do, okay, I've got a list of patterns, and rather than map them to arcs, I think what I want to do is patterns.reduce pattern.empty, and I don't know, can I say plus? Parameter 2. Well, I think I can do this. I can say $0 dot plus $2. Oops, 1. What did I just do? Now, I'm in them wrong. That one goes to a 1. Okay, so I'm saying take let's see, dot 2 arcs, and then this goes away, I think. Have I still got an extra brace? I don't have any to... No, I'm good. Okay. So I'm saying take the patterns, basically combine them. Normally you could do 0, comma plus. You've probably seen reduce that. I don't know if there's a way I can specify the plus method without this. Well, let's see if this works, and then we decide. But what I'm trying to do is concatenate all the patterns together, and then calculate the arcs on the patterns. All right, so let's see if the test works. And we have a dot, and they should be concatenated, and it should be 2 wide now. That's why I think the test should work. Yeah, all right. So let's run it. Okay, so I'm going to make a pattern that's like a little ball. Or something. Okay, a square. Next time, put the name in that should be required. And it's not going to detect that it doesn't care. All right, let me make that required field be on our to-do list, though. Okay, and we have an S. If we go back here, if I do S, oops. Trying to put enough in that I think we'll see the shape and recognize it. Yeah. Okay. I'm getting pretty happy about that. It's off center. That's a little annoying. Why would it be off center? That's bizarre. I mean, part of this thing with the Swift UI, you're specifying stuff and then you're letting it do the details. So sometimes there's stuff you don't get much control over, but yeah, you can see we left space in the ball. That's why there's space between these. And if we did that in the grid of letters, that would be okay. But what it makes me want... I want some way to specify, like, don't, how much space do I want for this thing? And maybe maybe that's something it could. Maybe we just need more experience to know. But that looks like what? 3, 6, 9, 12, 15, maybe 25. 25 of those things. And if it were real letters, I think you'd be able to read them. They're a little bit elongated. And maybe my LEDs are thus a little bit big. But that's coming along. Okay, let's see. So we did this. Let's catch up the details here. 21/6/30, the last day of June. The year's half over. 21-07, composite pattern that builds a sequence of patterns. Well, yeah. Okay, so we didn't do a composite. We give pattern a plus method that concatenates patterns. Pattern gets a plus method. Yes, that makes sense. Okay. Pattern selection, concatenate patterns. Well, I think we've done that. We've done the basics of it, but I'll give us a partial credit here. This will be details. So what's missing in my mind? Well, I would like to deal with this space thing so that I don't have to put spaces in my font. Let me see. Somewhere I saved. Well, we can find one online quick enough. 5x7 font. Probably images would be the way to go. Yeah, something like this. Now, what I can't tell. 1, 2, 3, 4, 5. Okay, so that is 5 and 7. So the spaces between them is the artificial thing. So I would like to say if you wrote A, B, C, D, E, you would have it spaced like this. That the spaces you're putting in are actually implicit long, tall, skinny spaces. And those get interspersed. Now, I don't know if a join could do that. Let's see what we got here. So I've got the map. I've got a list of these things. Can I say join? No. Well, there's certainly some way I can do it. Do I care if there's a space on the end? That's the real thing. Okay. Well, all right, let's put it in our to-do. So add space to patterns corresponding. Well, maybe it's just add space, add one column space between patterns. That's something I'd like to do. I'd like to have use colon to mean no space between patterns while I'm writing my wish list. Goodness. I think my keyboard is dying on me. Okay. Toggle pattern cell doesn't need to handle out of range. That's probably a good question. Well, mostly it's not going to matter. Right now we got it hard-coded to handle 5x7 pictures. And given the LEDs are, we're presuming a string of 7 LEDs. Okay. Another thing I noticed, we want color on our LEDs. Okay. I don't know what they have to be, but I like the color. um, so just, okay, require pattern name. Yeah, that's a good one. But I guess I want to separate in my mind, like what's fundamental and what's just like tweak, And another one on the UI, I mentioned the library should make a grid, not a single column. Should be a grid, not a single column. And another UI thing we've noticed, UI top is not centered. Okay, let's see if we see something obvious for that. Content view. Okay, content view is the basic high level view, and the way we structured it, which I don't know if it's just not clear to me if, like I've wished before, I wish I had a real a real Swift person with me here, a real iOS person. So what I've done is, well, content view is the top level view. If we go to our app, it's going to call content view. And we separated it out with navigation view to correspond to the three screens. So there's the main view, there's the patterns library, which calls library view, and then there's the edit pattern navigation view. Yeah, so that's where if you click the library new, you get to edit pattern navigation. Okay, and that holds the pattern. Okay. I mean, unfortunately, some of this stuff you just kind of have to have at the level up here. But anyway, the reason I've done all this is getting the navigation right was its own little trick. And I want to say the outermost layer of views that correspond to these three top level screens, they're interconnected, so I think there's no reason necessarily to split them apart. I could put them in separate files, but you'd still have to go from one to the other all the time. What I tried to do is, excuse me, I tried to make the edit pattern, well, I tried to give each one a single view to look at. So this has edit pattern, this has library view, this has content body view. All right, now let's go to content body view. It's like, do we see a reason why our stuff is not centered? So this is a vertical stack. This is vertical stack top to bottom. Z stack comes, around the screen, through the screen. So these arcs are overlaid over top of each other, basically. But yikes, I don't see any reason for that. Let's try something to force it to center. And a way to do that, maybe the way to do that, push this down after the Z stack, is to put it in a horizontal stack with space on each side. Okay. I don't know. This is, again, there's this philosophy that you should let it do the layout, but like we let it and it didn't come out the way we wanted. I don't know why. Well, no. I bet I can do something else. Can I put a center? Align. Can I put something in here? Alignment. Take out this stuff. Well, can I say dot center? Okay, let's see if that helps any. this is why I'm not a good UI person, because I just don't know the tweaks that you have to do. And obviously my sense of style is a little limited too. I guess I wanted to run that, not test that. Now, that's not centered if you ask me. There's that. Oh no, it is. Maybe it's just the off. Let's see our pattern here. Okay, rings 1, 3, 4, 5, 270. I'm gonna make it 360 and just see what happens. Oh, I ran the test again. I guess it's good in the sense that it means I'm testing a lot, so that's my default reach. Okay. I'm going to force that ring 5 to go all the way around, I hope. And with that, okay, that does not look centered to me. Okay. It does not look changed. We filled in 1, 3, 4, 5. Okay, this is really annoying. There must be some sort of like default frame leading blah blah blah. Swift UI view not centered. Wow. My I and my N keys seem to be sticky. I imagine he'll get it right from that. Swift UI view not centered. Really, I can't believe it. There aren't a bunch of people complaining about this sort of thing. Okay, I don't know what to look for. Let's go back to our code. Okay, so my view here, content body view. Let's make sure that's nothing in front of it, nothing out here that's going to make it go funny. Okay, here's content view. He has a navigation view. I don't think I can. Yeah, I can't do anything like that. Okay, I can't say centered. I don't think I can say alignment here. Alignment guide. What if I did frame? Can I say alignment center? But yeah, you can see. I mean, I'm not clear. I'm missing something about the model, and throwing stuff in that maybe will help, but I don't know the systematic way to get at this. But this navigation view is the whole thing. And I don't see anything in here that would make it off center. If I go to content body view, that's a VStack. Again, I don't think there's anything on there to force anything weird. I mean, I can do, well, let's run what we have. Z-stack alignment center I don't think changed anything, but let's see if we can get it. No. And alignment center. And I don't think I need to do the rest of that. I think I can do that. Okay. So I'm feeling like I've told it the outer frame is centered, the stack I'm doing is centered, the thing I'm drawing is centered. V-stack is vertical, so it's not supposed to do things side to side. It's like that thing about being lost. If you're lost often enough, everywhere looks like it's the right track. You know, this looks familiar. Okay. Now this is solid left. So what is going on? Where's my center on my V-stack, Z-stack? Maybe that's interesting. Arc shape. Let's go down to arcs. Line width. Oh. Okay. This is from early on. I need to do something different to get to the center. That sucks. Yeah. Okay. I mean, it could be 185 probably. 5 more pixels. On this phone. Right. I know there's a mechanism. How it's going to find it, I don't know. But there is a mechanism to say capture the sizes of the frame I'm in. Jeez. Capture the size of the frame I'm in and pass it down to the inner objects. Normally they don't get access to that. And knowing that exists doesn't really make me remember how to make it happen. Okay, that's close enough. I think the other thing I want to do, the line width, let's shrink that a bit. And these arcs, yeah. Okay. Yeah. All right. Okay. Let me say we've gone for a while. I need to take a break, so let's take 2 or 3 minutes, and we'll come back and pick up from here. Welcome back. All right. Let's see. So, okay, we've done a little tweaking here. Let's check in. What have we changed? Well, actually, I want to take those centers off because I think they should be all defaulting there. This one counts. Content body view. Let's take that off. Notice when I asked it to put one in, it was suggesting center, so it tells me it probably was not needed. Okay, content view, frame alignment center. Okay, because I think the more extraneous stuff I tell it, the worse, the harder it's working for something that does me no benefit. Okay, and then the diff here. All right, so we did 2 things. We made So a list of patterns is concatenated and displayed. Tweaked UI to show top in the center. Okay. I'm going to switch phones while we're doing this. So, well, how about just an iPad? iPad Pro. Okay. Let's do a run there just to show, like, my theory is it's not going to be centered. Do I want to deal with that now? All right, this is what we do the to-do list. Okay, so top is centered, or top should be centered with relative coordinates. Let's say it that way. Okay. Add a space, add not a space, color our LEDs, toggle the pattern cell, handle out of range subscripts. That's probably, well, okay. So that one, basically I'm using a 5x7 grid as the default. So in theory at this point, there's no way that would be an issue. We've done a little work to make it so patterns of different sizes work together, but we've left out toggling. Okay, so that's a thing. Let's see. So I don't know. I think there's a refactor double to probably arcs or something like that. Maybe this is a good point to just walk through everything. Okay, I have the notion of an arc. It's a display element. Well, it can be used as a display element, so I've made it identifiable. And this is an example. I have to the field, I can declare the extension down here, but I can only add fields up here, and it needs a description field. I could have done something to hard code it. There's not a good way to do it, I guess, is my short point. Oh, custom debug string convertible. Okay. Maybe I should force myself to do that on pattern tests. Okay, let's run tests with that. And I think if we make a test fail, we'll see it in action. Probably not that test. Okay, let's... Oh, shoot. I can't run tests. We're still launching our iPad. Okay, let me undo that. All right. I'll add it to this for a moment. Modify test plus temporarily to check debug message. Okay. All right. So arc is basically, it's it knows the ring. It knows what angle you're starting at, what angle are you delta, and it knows the color index. I don't know if it needs the color index. I almost think it doesn't need the color index. So let's put that as a question in here too. Does arc need color index? I think that's enough to know the ring, and we're not even using the color index right now when we draw it ourselves. We're using it. Well, let's see how that's working. content body view. Whoops, I just had it. Yeah, here we go. Okay, 1, 1, 1, 2, 3. It's got the colors. Okay, so when we draw it, we do draw the arc's color index. But I don't. Let me modify this a little bit. I don't know what colors I got. Yellow, gray. 0, 1, 2, 3, 4, 5. I need 6 total. Purple. Maybe gray would look nicer on the outside. Or maybe before the secondary colors. How's that? Blue, gray. Let's do that. Let's do red and green is purple. Oh, they don't really work that way, do they? I don't remember my color theory enough. Well, we got Roy G. Biv. Red. How about an orange? Okay. I got to make sure there's at least enough colors. 0, 1, 2, 3, 4, 5, 6, 7. Well, that's probably more than we need. Let's put black on the outside. Okay. Let's do that. Okay, let's do a run. Remember, we're trying to see if it's centered or not. What? Oh. Okay, it is not centered. Yeah, iPad's probably not the right choice. Okay, so it is not centered in this view. That tells me that. They say, oh, if you're navigating, well, you probably just want to have this top level view as your outer navigation, and then you can go to patterns and new and do your stuff, and you know, that's fine. If I'm triggering. Okay. Yeah, I mean, it's just the paradigm they shift to. I'm sure there's a way to enforce it, but we did an iPhone style navigation, and I think we'll stick to that. Okay, but I'm going to quit this simulator, go back to mini. Well, actually, let me go back. Well, it shouldn't be any slower. Let's take the Pro Max. Okay. Running tests, and then I'll run the real thing. Okay, and again, that's going to take a minute to get going. Okay, so, well, what I've done so far, I've added colors to make sure it's got enough colors for any ring number, and I want to just index off the ring number rather than make the arc know that. Okay, so let's just accumulate stuff for now. How about remove color index from arc, use ring number instead. Okay. Yeah. All right. So that's arc. We're gonna remove color index. It's not much of a class, right? It's just a data bag. I think this is probably a test thing as well. I probably could pull it out. I don't know, this may or may not be a test thing. And it's kind of a naive thing, right? Because like I did start at 270 and 360 degrees around. That's pretty darn similar to start at 0 and go 360 degrees, you know? Okay. But that's the arc. All right, our tour. Okay, the top. There we can see this array of doubles turns into an array of arcs. And I don't know why it can't earlier. The doubles. Oh, yeah. So the doubles are not arcs, in fact. Okay. So let's make our to-do realize that. So the how reflect a relationship between double and arcs. Okay. So the relationship there, this list of doubles is really the dash patterns. So each row, you know, each inner array is a list of dash patterns: on, off, on, off, on, off, and without regard to the total distance or anything. This function spin basically converts them to actual arcs, which tell you their position in degrees and delta and all that. That's this method that's doing all that. Oh, there you can see a reduced 0 plus. Okay, so we add up all the dash counts and then divide by 360 gives us total distance, and that tells us how much each little tiny arc is. You know, for 1 unit on of dash time. Okay. I don't know. Is that the dash, a dash pattern? Dashes? Maybe one of those arrays is a dash. And okay, yeah, here we go. iPhone 12 Pro Max. Different screen size, hard-coded center. Doesn't work. Okay. Doesn't work the way we want anyway. Okay, I'd follow 12 mini. I hope the mini runs faster is all. Less to draw. Okay. Let's find that test. Okay, to do test plus, yeah. That's on pattern and pattern tests. Okay, so I'm going to make this false. Run my tests. We don't have to restart the i12 mini, so I'm just trying to see the error message, make sure custom string debug convertible produces a reasonable message as good as the other did. Okay, so let's undo that. Run that again just to double check. Okay. Well, this is not what's really going on. It's really switch pattern to use custom debug string convertible. Okay. And let's reflect that. I think I had something else I did in there too, but that's the way it goes. All right. I guess I'll continue the tour here. Okay, we had top. Here's library. I think this one's okay. It's pretty minimal. The interesting thing maybe is it's observable and has a published field. That's so our UI can work with it. But otherwise, it has sort of stuff you'd expect. It does sort the keys when you ask for them. That way our library comes out sorted. That's the only twist, I think. All right, pattern we spent a lot of time on yesterday and today, so I'm not going to spend any time now. All right, now we're in the view side. This arc shape thing, yeah, that I should mention that in our to-do. I lost my to-do. Okay. Can I go back to it? Okay. Word relative. Yes. Arc shape. Okay. I don't know. We spent enough time in all those, I think, for today. Oh, could that be better? Well, we know we're going to be in here again, dealing with these separator spaces at some point. Okay. 11. I don't think we need to walk through the tests. Here I mentioned the app. This is the Swift UI way to create an app. You create a scene. It has a window group containing a content view, which is that top level view class. All right. All we've done is that. Okay, let's do this. Okay. I'm going to put this over here. I'm just going to close other tabs. Is it open? Arc. Okay. All right, we don't need this. Okay. Oh, apparently we do need that. Who knew? Whoops. Finally. They give it to you all the time, and you only need it for a few things. Double and int and all that, you don't. Okay, so I'm saying color index, who references it, and let's get it out of there. Okay. Content body view is the only use. All right. So I would like to say, don't do color index, do ring. Is that not a field on there? I thought it was. Yeah, it's on there. Okay. So ring number instead. All right. So if we run this, let's see. Well, the string, the colors are going to change. It was 3, 2, 1, 1. So it was something something. I remember the outer ones were red. So yeah, this is reflects our new color scheme. The fancy gray LEDs. You don't see those very often. Okay. All right. So now nobody's referencing it outside this class, so we can just basically remove it and deal with the consequences. I think it's probably the fastest way. What did it just say? Color index equals color index. Okay, so I'm gonna take that out. Well, let's do it more properly. Let's just take this out. Now, lots of people should complain. Anybody who called it and specified it is got the extra arguments. Okay, not a whole lot. So I'm splitting up how much breaks. Okay. What's your problem? I don't think that's real. Okay, now nobody's using it. Let's take it out. Cannot find color index. Ah. Okay, we don't use it anymore, so it doesn't belong in our print. Good. Okay, now let's move this to the arc tests. No, let's check in. Well, it's not really a refactor. It's change ring to or change top to use ring number instead of color index. All right, now this I'm going to pull out. Whoops. Pull out. I want to find the arc tests. Put this up here. And let's see if it builds. I guess I'm running tests too. And I think the same thing is true here. Identifiable it needs, but this equatable I think we just added for testing purposes. Okay, so I'm going to do a clean and a test. Take a little longer to build, but I think it'll give us more confidence that that's only belongs down there. And if it built, it probably will work. Okay. So we removed custom debug, or moved custom debug string convertible and equatable to tests. All right, I'm seeing some sort of network error triggered. Hopefully it catches up. We'll just see if that goes back on. Okay, looks good. All right, so that's the arc. It's a pretty darn simple class, which is not necessarily a good thing, but I think it's also acting as a sort of a display element. This use of identifiable, when this view changes, this identifiable thing lets the front end management system know that it's dealing with the same arc, and if it's in the same arc in the same place, it's like I don't have to redraw it. I know you're the same. And maybe equatable could almost just compare descriptions, couldn't it? But okay, I think we're good. All right, what else we got to do? Remove color index, yes. Okay, so I guess I've got to look and say what's essential and what's not. Because my plan is we'll do our session tomorrow, so I've got basically 2 more hours plus the 20 minutes today. It does what I wanted it to do, and the rest, so I think now we're just at the point of like we're improving it, and it's like what has to be done to make it right. Okay, so a color on our LEDs. Let's see if that works. Am I still running? No. So I would like that to happen. Toggle pattern cell. Does it need to handle out of range? That probably can move down. This one I'll move up. 1 column space. That would be interesting. It's one of those things, if I were really using it, I would probably have to. I guess the other thing I could do is pre-populate the library with space and letters and punctuation, something like that. That'd be nice to have. I mean, it's kind of boring to watch me type in, false, false, true, true, false, false, false. We would certainly like to have some little easier language for that. But watching me type a bunch of letters in would be boring. I don't see another way to get it in there, but, nothing reasonable anyway. All right, color, 1 column space, yeah. Require a pattern name. on save. That would teach me something. I'll put it up here. Library should be a grid. Again, I don't. It would teach me something. Top should be centered with relative coordinates. Yes. Relationship between lists of doubles and arcs. I don't know. The doubles. It's this thing. I did this stuff to convert the pixels to runs. And the runs are basically those doubles. That's the dash patterns. And then we convert the dash patterns to arcs. That sort of represents the timing thing of the top simulator part. I don't know if that class is pulling its weight, really. Like, maybe the only... Well... Maybe I should be producing arcs instead of lists of doubles. Would that be an improvement? And the doubles could still be there, although I only used ants, really. Because it's counts of pixels, it's counts of pixels that are turned on or off. And maybe if only arcs came out, it's like there's a line. One side is the simulator, the other side is the design mode. And the design mode should produce what the simulator needs. Excuse me. And so it's kind of a question in my mind. It's like, should I be telling it run lengths or should I be telling it arcs? Arcs is a little bit... arcs is the geometric translation, right? The actual input, I think, is the list of doubles. The doubles are the dash patterns, and it's going to turn into a timing thing. Basically, it's like it tells you how many, modulo some constant. It tells you how many milliseconds, say, it should show up, or maybe it's more like tenths of seconds. But you should turn on for, if you're, I don't know, I had a slide way back about the physics of this. Our top has 20 revolutions per second is my guess. So in 0.05 seconds per blip. 20 revolutions per second. So if I did 0.05 times 20, that's 1 second. Yeah, so each revolution is 0.05 seconds if I've calculated right. And okay, it's 20 revolutions per second is how many seconds per revolution. It's 1/20th 0.05. 0.05 seconds. So you divide that into 360. That tells you how long each second is for a degree of range in our stuff. And so, yeah, I guess this does seem like what you're programming it with. You're giving it a list of timings for on, off. And, the little program inside is just go through the list and turn it on for that long at each point. Maybe there's some sort of inversion of the list that's like, at what number do you start? That might have been a better simulation side. If you just said at what millisecond or at what percent of the revolution do you start on or off? And then you could imagine a timer clicking through and saying, oh, am I greater than 150? Yeah, turn on this, and but yeah. Okay, this one I'm almost certainly not going to mess with. Not interesting enough. Okay, let's get color on our LEDs. In a way, it's distracting because I've treated it as pixels, but maybe we can do something. Okay, so we'll create one. One C-like letter. Call him C. Okay. And if we do C. Okay, yeah, so this is the kind of sparkly stuff you like. But my goodness, can you see a C in that? I finally remembered. I was trying to remember the video game Tempest. I don't know if you ever played it. It's very old school, but you had these aliens coming at you from the center of a ring, and they would expand out towards you as they got out there. Now, this is a pretty pattern, right? So that's something. I don't know. I'd like more red in it, but that's maybe fewer colors would be a better deal. But we do have colors now, so that's good. That was the change from color indexes. Somewhere along the way, we hard coded it to 0, and we had a default equals 0, so it came up 0 a lot and pulled in the black. Okay. I don't know. I think fewer colors might be better, but that's okay. That's a tweakable thing. Okay, so we kind of got this for free. Okay, what's next? Require a pattern name on a save. Okay, I could probably pre-populate. I'm thinking of this one column space thing. Let's split out pre-populate space. This is not a real space. It's a 1 pixel space. Okay. And the goal with that is I would like to then use that as a default in our patterns. Figure out that join thing I tried. Okay. We only have 10 minutes, so we won't get this thing done, but I think that's a good next step to tackle. So if I did that, and then maybe focus on these two tomorrow. Get these, and then we'll leave this as an exercise, I guess. Okay. I mean, if I wanted to tackle this more and learn more user interface development, there definitely are some things in there that we can work on. But how about and one letter? Okay, just to give myself something easy. All right. So where's that created? Well, let's go up here. Content body view. Nope, I wanted content view. Where's our library? I'm inclined to be lazy. What if we said the library automatically includes the pre-populated ones? So if you create a library, you should get, oh man, but our class is so generic, it doesn't know these things. Let's give it an initial list. Library, I'm going to say you are allowed to give it an initial maybe it's like this, initial contents, and that's going to be key to pattern. So we'll let you pass in a hash table. Okay. I don't know why I'm pushing for a generic thing. I may be making things harder for myself than I need to. Okay, but if you do this, then we should have that should be equal to empty. Okay. Let's see if that builds and runs. It should. Okay, and now we can make some tests. Library tests. Okay. Whoa. From test. Library initial values. Library. Well, let's just do string just to keep things easy for us. Okay, default value empty. No, he's got to be a string. Okay, and then let's make a map. A goes to apple and B goes to banana. Banana. Okay, and I think I have to put the initializer in. Oh, colon. Okay, do I have to say initial value? I think I do. Yeah, contents. Okay. Okay, so now I made my library with the initial stuff, and I should say assert equal library.keys is A, B. Is that enough to give me confidence that it's put the stuff in there? I think so. Okay, this test should fail. All right, empty is not equal to AB. Okay, and here we're going to say dictionary dot merge keys with combine. It looks so hard. Let me find an example. Lazy. That's good lazy, I hope. Okay. Merge dictionary Swift example. Keep the current if there's a duplicate. Okay, I guess that's what I want. I specify an override policy, basically. Okay. And I don't think it's going to matter. Dictionary merge initial contents. Keep the new. Again, because it's the initializer, I don't think it really matters which one we do. Now, I don't know if this is merging in place. Quick help. Merge the given dictionary to this dictionary using combining closure to determine the value for duplicate keys. Okay, it sounds a lot easier like that. All right. Test should pass. It should all be good. Okay, now in our where we create our library, which is content view. Yes, here we can say initial contents. Let's call it space, and its value is a pattern. The pattern is false. Okay, so one false pixel means its width is going to be 1. Its height will be whatever the other objects are. Type of expression is ambiguous. Sorry, that should be a colon. Okay, so if you put in a space as the word, pattern should be false. You should get a one pixel space, not for tracking purposes. All right. And that should basically mean our library is pre-populated, but it will look like a full 5x7 space, but it won't be, I don't think. Oh, I'm very curious now. It's not. Okay. It's just the space. Okay. Now, I think, let's see if we can do this in 1 minute. Back to Top Maker. Okay. Pattern split. I think there's another way to split. Max splits and omitting empty sequences. But I want the spaces. Can I get the spaces? False. The returned array contains empty strings where spaces were repeated. Okay, it's not going to do that for free. All right. Well, I think we'll pick up there tomorrow. Okay, so we populated a 1 pixel space, sort of, and maybe the name is not right. That thing we just looked at only did 2 spaces at a time, so it's not going to be suitable. But 1 column space between patterns. All right. So I think if I can make the patterns break up but keep their spaces when they do, there's probably a tokenizer thing or something that'll do that. We'll try that tomorrow. Tomorrow is Thursday, 1 to 3 p.m., and we'll pick up there. Thanks for joining me today. Catch you later. Bye-bye.